Welcome to this exciting journey into the world of Docker. Now there are set of videos planned in this Docker series, but in this specific video we will try to understand Docker through some real world example, so that correlation will help you understand how Docker came into existence and how it actually solves the problem. It will help you explain this concept in a real way to anyone, even to a layman. It will it will strengthen your understanding of the Docker, and in the subsequent videos we'll talk about, or we'll do lots of hands-on exercises that will eventually help you master this concept. This is the agenda for this video. So we'll try to answer three basics questions in this video. What is Docker and its real world analogy? As I said earlier, this real world analogy will help us understand what was before Docker. As we know, it's virtualization, and I'll explain that in detail later in the video. And what's the parallel in the real world for virtualization, and how there were issues in the virtualization, and how Docker came into existence, and what's its real world equivalent. And that story will actually help you and deepen your understanding regarding Docker. Once we have answered that, we'll move to the next question: why Docker? Like, what are the real world advantages of Docker? Why Docker is gaining so much traction? And now we talk about backend development. The Docker has become a de facto tool or a technology that we use for backend development. After that, we'll do a deep dive into how Docker. Now, we know Docker is important. We know it's lots of advantages. But what are some of the things which works under the hood for Docker and how it works? I want to just brush over like what is under the hood Docker, meaning what powers Docker. And once you've gone through some of the videos, once we have some hands-on experience, I will go into the details how it works under the hood, and how this technology has came into existence, and why this is such a boon for a backend development. So here we are, Docker and its analogy. So in this section we're going to talk about or I'm going to tell you a short story, a beautiful story, which can help you understand Docker in a correct way. And and you can also relate with this story actually, because it's quite common, it happens with everybody. So let's get started then. So on your screen you can see a character, or let's name this character as Ira. Let's imagine that Ira is a fresh computer science graduate. After graduation, she also got a good job in her hometown, and she's very happy about it. Let's imagine today is her first day to join this new office. Everybody at her home is excited as well. So her mom packs her favorite lunch in a newly bought lunch box. Taking lunch boxes to the office is quite common in India, and maybe it's might common in other countries as well. Basically, it saves tons of money. Take a look at what does the lunch box looks like. That's how it looks. Isn't that lovely? We got so many items of curries and rice and wonderful colorful vegetables. Anyway, let's get back to Ira. So Ira takes this lunchbox to the office. She attends the orientation session held by the HR team. She meets her colleagues and makes new friends. Now it's already time for her lunch. Ira opens up lunchbox and gets shocked to see that everything is messed up. Now I don't have a picture to give you how does the lunchbox looks like, but imagine this curry is all over the place, and this dry veggies is all around the place. Everything is messed up. So curry is spread over the naans and the chips. Everything looks messed up. I don't have a specific picture, but imagine that. And Ira was looking forward to eat her favorite food, but things turn out to be different. She does not feel like eating that food at all. she's feeling angry but can't really help it now. She grabs something to eat from the office canteen and goes back to her work. She comes home, she's not very happy, she narrates this incident to her parents. Now her mom is thinking about what could be done about this problem. Definitely the flat lunchbox is not really helping. So the lunchbox that her Ira's mom gave wasn't really did not have a great packing, and it wasn't meant to absorb the shock of a traveling that Ira did from her home to the office. So her mom goes out to the market and buys another tiffin box. Now this is how this tiffin box looks like. This tiffin box has proper containers to keep each atom, atom separate from every other atom. The curry does not mix with chapati, and finally Ira can enjoy her favorite food at the office. Now I want you to remember this story, and we are going to revisit the parts of it when we talk about Docker. In simple terms, the first tiffin box, the first flat tiffin box can be considered, so the tiffin box on your left, that can be considered as a monolithic application which had created a kind of a mess. Now we'll talk more on what is monolithic application in detail later on, and or I'll create a separate video and link it here. And next, Ira's mom bought her a new tiffin box which is on your right. Now this tiffin box has separate containers to store each food atom, and these individual containers are nothing but Docker containers which are trusted to handle only one thing. Imagine 3 Docker containers coming together to serve your best lunch, or to serve you or give you a great app that you want to build. Now each lunchbox container was packed with only one atom, but each atom has its own complexity. For example, let's imagine that you pack a sandwich in one of the containers. Now sandwich has cheese within the bread, it has tomato slices, cucumber slices and whatnot. So there is a complexity involved, but that sandwich is one as a whole. Similarly, a Docker container will be responsible for only one thing. For example, let's take an example of auth service. Okay, auth service, the job of auth service is to verify or authenticate users. But if you look within the auth service, there will be many libraries, many npm packages, or the third-party endpoints that auth service is connecting to. But auth service is hiding all that complexity and providing you some interface to connect with. Okay, so that's the overall story on Docker. I hope on a high level you understood what Docker stands for and how they should be used and what's their main purpose. It is to handle only one thing at a time. Let's now discuss why Docker. To some extent, we did speak about why Docker when we briefly mentioned monolithic application and how it creates a mess when not handled well. But let's do a deep dive here. Why do we really need Docker for? So first point is, if you have not worked on Docker before or you haven't done any development on Docker, then you might have come across a situation where you see something working on your machine but not on your colleague's machine. Such issues are often reported by QA team that certain functionality is not working as expected, and then when you check it on your machine, it seems to be working fine. And this difference could be underlying hardware or set of tools which are required to run the application. It could be also dependent on the specific OS versions, and things can vary even for the minor OS version as well. Now with Docker, these issues get completely eliminated. I have another analogy here. Okay, we know C or C++ is a platform dependent, whereas Java is a platform independent, which means you compile once and run anywhere. So if you look at this diagram on your screen, every Java program gets compiled into a bytecode. Okay, and then this bytecode can be run on any OS, be it Linux based, Windows based, Mac OS. And do you know why it works, why we need to compile once and we are able to run it anywhere? Because on all of the machines there is a thing called JVM, which does the heavy lifting job of converting that byte code and making it compatible with the host OS. That's how Java becomes platform independent. Now on the similar lines, we have a Docker daemon. Now when Docker daemon is installed, it will make sure that applications run the same way on the multiple platforms. So if you look at this specific diagram, you have this multiple containers, app A, app B, all these containers. So this Docker daemon or this Docker environment is responsible for making sure the translation of the instructions when the app is trying to communicate something to the underlying OS. This Docker's daemon is responsible to translate those instructions based on the host operating system, and this operating system can be Windows, can be Mac, and your container will seem to run the same way on multiple platforms. Also, since you pack everything under Docker container, your environment actually never changes, no matter who installs it or when it gets installed. If you pack your Docker, let's say if you pack your Docker image with node 17, that it remains same across all the installations, be it dev environment, Q environment, dev machine, be it Linux OS or Mac based OS. I hope this clears the importance of how Docker helps in these situations. Now the next point is regarding ability to scale independently. Now in the current world, we want everything online. Our grocery is online, our shopping is online, our money transfer is online, and it's an integral part of our lives now. Because of this, traffic for, like, no matter what service you develop, the traffic for that service goes up by many folds. Your compute requirements, storage requirements, everything has gone through the roof. Each service has different compute power needs. For example, you have 1,000 users signing up per hour for a specific service, but you may have 10,000 users browsing the shopping catalog. So you need more computation power for shopping catalog than your auth service. So we need an ability to be able to scale independently. With monolithic apps, this becomes a challenge where you cannot scale a specific module. But in this use case, Docker container with specific purpose, Docker container built with a specific purposes help you to scale a specific service. For example, auth service might not need that much computation power, so it can scale to a certain limit. But let's say browsing a shopping catalog needs much more computation power, so you can scale that with a more number of container than the auth service. So that's the very important point of scalability. Now next point is another advantage of Docker is flexibility. Let's talk about how it helps. Now because there is a separate container for each service, then you can choose to write each service based on your needs. These needs could be your team's experience, a specific programming language. For example, if you have an auth service in Node.js and let's say there is shopping catalog service which needs to handle higher concurrency, then you can choose to write that specific service in a Go language to support your concurrency needs. This also helps you in revamping your infrastructure in future. What does that mean is, let's say there is a new programming language which runs at a speed of light. Everybody, all your colleagues are talking about it. Then out of 50 services that you have in your application, you can choose to experiment and rewrite that service in a new programming language just to test this out. This way you reduce the risk and you also reduce your tech debt, and it happens in a step-by-step fashion without stopping any services or without shutting down all the services. This way you can continue to improve your platform in a step-by-step fashion. I think we talked enough on why Docker. Now let's talk about how Docker works under the hood. what are the technologies and tools that are used to make this Docker work and also being lightweight. In order to understand Docker, let's understand what is virtualization. In layman's term, it is a computer within the computer. That's a very crude way of saying it, and very basic picture actually for you to visualize what is VM. So you can see the picture on your right. So there are multiple computers. So we are talking about computer within computer. That's when that's what virtualization is at its core. For example, imagine you have a great computer with 30 TB hard disk, 128 CPU cores, 248 GB RAM. That's a big beast, right? And the cost of such computers is very high. And if you don't utilize it to its fullest, then it will be a waste of time, waste of money and time as well. Now, using the concept of virtualization, we can have multiple VMs in this computer. Say you want to build 5 machines within this, let's say with the configuration of 4 TB hard disk, 32 GB RAM and 16 CPU cores each. We can do that, and multiple people can use this VM without affecting the other VMs, meaning once you have allocated the specific configuration, then it is reserved for you physically, even if it is underused or overused, but you will not get, let's say, more disk or RAM than what is allocated in that VM. So the picture on your right is basically what virtualization does. So we have this virtual machine monitor, and on the top of that you have actual virtual machines, and they have their own OS. So they come bundled with everything, just like a normal computer. This is how your EC2 machines in Amazon or AWS works, right? This is the exact concept that they use. But then how different is Docker and how does it work then? As I said, like, main difference between how Docker and VM technology work is that when a VM is installed, it comes with the entire OS installed along with it. But Docker uses actually the host machine OS, meaning Docker will, when you install a Docker container, it will not have its own OS, but it is going to use the OS of the host machine. But then who is going to translate the instructions? That's when the Docker daemon comes into picture. So Docker daemon, which is responsible for translating those instructions. Basically the main components in Docker, so let me go to the next slide. The main components in Docker are C groups and namespaces. With C groups, the Linux operating system can easily manage and monitor resources, resource allocation for a given process, and set resource limits like CPU or memory or network limits. And namespaces are helpful in isolating the process groups from each other. You don't want your Docker container to be writing on the namespace of some other Docker container running, right? That wouldn't be the actual virtualization or actual use of the Docker. But some of these main libraries which helps you isolate one Docker container from other container and actually use the host machine OS as well. And there are 6 default namespaces in Linux, which is MNT, IPC, NET, USR, PID, and UTS. Each container will have its own namespace, process running inside that namespace, and it will not have access to anything outside its namespace. And along with this, we have this netlink, netfilter. These are basically used for network isolation. You don't want your network to be collapsing with some other Docker container. So this is how Docker is different. This is how Docker is lightweight than the virtual machines. I hope you understand the overall concept on Docker and how it is used. We talked in an ideal sense that Docker container should be used for only one thing at a time. Having said that, that is the recommended way of doing things, and with the advent of microservice architecture, right, you want to be using a single container for a specific purpose, but that's not only Docker is used for. Docker is basically a container. So if your application is small and then you don't see the need to scale each module independently, then you can very well package your entire application within a Docker container and use that Docker container, or scale that Docker container but you will not be able to scale individual modules. I think that's a wrap on this theoretical topic. I don't know if I bored you, but this is the theory that we needed to have before we actually get on with the actual hands-on exercises. And what we are going to do is, after some hands-on exercises, we will again come back to some of the theoretical topics so that we continue to refine our understanding regarding some of the insights on the Docker. I hope you like this video. Thank you.